direction here, the dependent variable, there's natural fluctuation in the dependent variable. And also there's fluctuation in job satisfaction, the independent variable. And we're trying to understand the dependent variable. So really what we're trying to understand is we're trying to account for the variation in it, okay, based off the variation in job satisfaction. Okay? And what this model is saying to us here, 0.756, is that the R squared value is telling us that 75% of the variance, yeah, or let's say of the variation in our dependent variable can be accounted for through the variation in our independent variable. If I was to put that in English, what it's saying is this, is that we can account for 75% of a person's or of this sample's intention to leave, yeah, okay, by looking at their scores that's associated with their job satisfaction. So we can account 75%, which means it's 25% unaccounted for variance, which is probably going to be accounted for through other variables, like maybe the gender, the age, and so on of the participants, yeah. Okay? The ANOVA box is telling us how good the model is overall. Okay, it's a sort of a goodness of fit sort of statistic. The significance here is 0.000. Once again, the null hypothesis is that the model is, I suppose, let's maybe bring it down to ground. The null hypothesis is that the model is not good. The alternative is that it's good. If the p is low, the null must go. That's our little rhyme, yeah? In this case, it's 0.000. It's less than 0.05, the significance level that we usually set for a statistical test. So there's evidence to suggest that this is actually a good model, yeah? But really what we're interested in is we're interested in these coefficients here, okay? So what I have is I have two numbers here. I have the constant term. The constant is 0.678, and job satisfaction is 0.857, yeah? So let's just have a look at that from an equation perspective, yeah? Maybe I'll just open up a Word document here really quickly, okay? Let's just open up Word, and I'll just write out this equation, okay? So here, let's go in here, okay? And let's write out the equation. Can I insert an equation here? I think I can. Let me just move this across. I think I can insert an equation. I should be able to. Oh, there we go. I'm just going to insert an equation here. Okay. So the equation is going to say this, that intention, let me just do this a little bit better here. Intention, why did I not go uppercase? Intention to leave, okay, is equal to, well, it's equal to 0.678, that's the constant term, plus 0.857 times your job satisfaction score, times your job satisfaction score. Okay, maybe I'll just make that a little bit bigger so that we can actually see it a little bit better. Okay, let me just do this size 18 font. Okay, so it's size 18 font. Okay, so your intention to leave is associated with job satisfaction, and this is the relationship. So if I know your job satisfaction score, if I multiply it by 0.857 or 0.857, and if I add that on to 0.678, that's going to give me a measure of your intention to leave on the intention to leave scale. And don't forget, actually, we did say that this was intention to stay. We relabeled it. So if that score is big, it means you're more than likely going to stay. If this score is small, it means you're more than likely have an intention to, you're more than likely going to leave the organization. Okay? So that's how we interpret the coefficients. Okay? But there is one other thing that we need to take into consideration, and it's this. It's random error. Yeah? It is possible that job satisfaction doesn't have any part to play in relation to the relationship with intention to stay, okay? In which case the coefficient here should be 0, okay? Because if that was 0, okay, let me just go back in here. If that was 0, this equation here would be 0 times job satisfaction, which means no matter what your job satisfaction is, 0 times it would not affect intention to stay, okay? So the question from a hypothesis perspective is, should that value be 0, okay? Or is there evidence to suggest that the value that we've observed is actually real, okay? And what we do is we go to the significance here of the coefficient, associated with the coefficient. In this case, in relation to job satisfaction, 0.857. Its significance is 0.000. Actually, it's probably quite small. Let me just actually hover over that there. Actually, you can probably hopefully see that there. It's 3.3393 by 10 to the minus 22. So it's effectively 0. It's tiny, okay? Which means the null hypothesis is that the coefficient should be 0. The alternative is that it's not 0. Once again, if the p is low, the null must go. And clearly our p-value, our significance, is less than our significance level, which is 0.05, or the 5% level. So there's evidence to suggest that this is a real value. And likewise, in relation to the constant term, there's evidence to suggest that that's real as well. Okay, guys, a lot of output there, okay? A lot of stuff to interpret, but I think from a let's say a process perspective, just take it table by table, try to get a grasp on what's going on within each table, and eventually you'll understand the whole model. As I said now at the start of this video, this particular analysis here, this regression analysis, okay, analyze, regression, linear, okay, we were just dealing with a single independent variable and a single dependent variable. You can throw more variables in here, okay? You can throw whatever you want in there to create a multiple regression model, okay? But we'll do that in a later video. Okay, guys, once again, my name is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And I hope this video was somewhat intuitive and more importantly, I hope it was helpful, yeah? Okay? So once again, thanks for watching.